Hi, welcome to another video on control systems. In this video we will try to solve some designs where we can find the system gain of a system for a given specification using Bode plot. Okay, let us try to know these things. So you should be in a position to differentiate what is root locus gain and system gain, and you should be knowing how to plot the Bode plots, how to find phase and gain margins, and more effectively how efficiently you can able to use a scientific calculator. Okay, with that we will start today's video. Just take okay, let us consider the transfer function GFS into HFS. It's a open loop transfer function of a unity negative feedback system. So let us take the transfer function as K by S into maybe 1 plus S and 1 plus 0.02 S. So this is a transfer function. So let us consider we are asked to find the value of K for a gain margin of, let us take a gain margin of around 15 dB. So this is the question that is asked now. So in such case, since the value of K is asked for a gain margin of 15 dB, first and foremost thing how we have to start is, because we know that in order to plot the Bode plot, we need to know the system gain and the pole positions. Certainly we know the pole positions. There is a pole at origin. So if I write the pole 0 plot of this, so there is a pole at origin, and there is a pole at -1, and there is a pole at -50. So these are the pole positions of this open loop transfer function. In order to plot the Bode plot, we know that we are supposed to know the value of K before we start, and then we can find the gain margin, phase margin. But here it is just the reverse is asked. So we are asked to find the value of K for a gain margin of 15 dB. So in such case, first and foremost thing to start, what we should do is, let us assume the value of K as 1, plot the Bode plot, find the gain margin for K equal to 1. So this is the first thing you have to do. Find the value of K by considering K is equal to 1. You are asked to plot the Bode plot. So once you plot the Bode plot, you can certainly find the gain margin. So after finding gain margin, so second step is, so using the equation 20 log K is equal to gain margin with K equal to 1 minus of given gain margin. So that is, given gain margin is like 15 dB. So assume that this comes out to be, of course this is in terms of dB, this is again in terms of dB. If the given gain margin is X, and if this is this is obtained gain margin with K equal to 1, if it is X dBs, assume that this is X dBs, the given gain margin is 15. So now whatever the difference comes, so that should be equated to 20 log K, from which I can find the value of K as equal to 10 to the power of X minus 15 by 20. This will be the value of K. So now X is in terms of dBs, which actually represents the gain margin of this system with K is equal to 1. So we can actually get the value of K using this equation so and so. So let us assume the value of k is equal to 1 and start plotting the graph. So when you assume k is equal to 1, so what will be your GFS into HFS? So GFS into HFS will now become 1 by S into 1 plus S 1 plus 0.02 S. So let us find magnitude at origin, which is, okay, let us assume the origin frequency as 0.1 radian per second. Then magnitude at origin is given by 20 log 1, that is this, minus of 20 log omega ORG. So we know that when you're substituting, of course this comes out to be 0, whereas this comes out to be, when you substitute omega ORG is equal to, that is omega at origin, if it is equal to 0.1 radian per second. So 20 log of 0.1 is minus 20, so it is minus 20 dB. So this happens to be 20 dB. This is 20 dB. So what is this? Magnitude at origin. So once we know this, we can write the slope table. Now this is what we are trying to do, is with k is equal to 1, we are trying to plot the graph. So let us write the slope table with this magnitude at the origin as 20 dB, which can be easily written for these pole positions. So I can write the slope table for this transfer function, which is nothing but writing all the terms in the increasing order of the cutoff frequency. This is terms, and we have the cutoff frequency in terms of radian per second. We have the individual slope by each of the pole or 0 in the transfer function, and what is the resultant slope, that is addition of the slopes prior to the cutoff frequency and after cutoff frequency. The first term is 1 over S. So since it's a pole at the origin, it doesn't have any cutoff frequency. Let us not write it. Of course, this has got a slope of minus 20. Of course, this is dB per decade. This is also dB per decade. This is also minus 20. Then we have next term, which is 1 over 1 plus S, where the cutoff frequency is 1 radian per second. So this is again having a slope of minus 20 dB per decade after 1 radian per second. So after 1 radian per second, resultant slope becomes minus 40 dB per decade. So we have next term as 1 over 1 plus 0.02 S, which has a cutoff frequency, which results in a cutoff frequency of 50 radian per second. This is also having a contribution of minus 20 dB after 50 radian per second. So this overall slope becomes minus 60 dB. So magnitude at the origin is 20 dB. So with this information, we can able to plot the graph. Let us also know what is the phase equation phi, which is nothing but, for this it is minus 90. So it is minus 90 degree minus tan inverse of omega by 1 minus tan inverse of 0.02 omega. So from this we can actually find out what is omega PC. So that can be obtained by equating these two. Minus 180 is equal to minus 90 minus tan inverse of omega PC minus tan inverse of 0.02 omega PC. Let me find out what is omega PC now. So this omega PC now is equal to, so minus 180 alpha equals minus 90, no need to simplify anything, plus minus of tan inverse of alpha A minus tan inverse of 0.02 alpha A. Let me just calculate that. Shift cal twice, I will get the value of omega PC as so omega PC is 7.07 radian per second, approximately 7 radian per second. So let us plot the graph and try to find out what is gain margin, that is magnitude at 7 radian per second. which we can find theoretically also. So since we are asked to plot the graph, Bode plot, let us plot it. Let us take the magnitude as 40 dB at the top. So let this be 20, let this be 0, let this be minus 20, minus 40, minus 60. So let us take the origin frequency as 0.1, 1, 10, 100, 1k, sorry, 10, this is 10, 100, 1k, and 10k. This is omega in radians per second. So now we know that magnitude of the origin is 20 dB. Initial slope is also minus 20 dB per decade. So I can draw that line. So I'll come down by 20 dB. Okay, please see here. This is magnitude at origin, which is at 0.1 radian per second, which is at 0.1 radian per second. I'll come down by 20 dB, go by 1 decade. So this is 20 dB per decade. So this will go up to 1 radian per second. So this is there here, 1 radian per second. I just draw it. So now this is 1 radian per second. So at 1 radian per second, the slope becomes, at 1 radian per second, slope becomes minus 40. So what I'll do is, I'll come down by 40 dB. I'll go by 1 decade. So this is 40 dB per decade. So per decade means 10 times the frequency. Now if I join this will be a, okay, till where I should join? I should go till this slope of minus 40 dB will continue till 50 radian per second. So I will go till 50. So where is 50? This slope continues till 50. Now this is 20, 30, 40, 50. This is 50 now. See here? This is 50. Now if I write the slopes, this is minus 20 dB per decade. This is minus 40 dB per decade, and at 50 it changes to 60 dB per decade. For 60 dB per decade, I need to come 60 dB down. Unfortunately, I don't have that much space here, so I can write minus 60 dB per decade as equal to minus 18 dB per octave. Meaning, here you can see we actually came down by 20 dB, gone by 1 decade. So which is 20 dB per decade. This I can also write it as minus 6 dB per octave. So these two are equal. If you can carefully note this here, when I'm just coming down here by 6 dB, if you just go twice of this 0.1, this is 0.2, can you see it's exactly 6 dB per octave. Again, if you can see here, I'll come down by 12 dBs, and if I just go exactly here, can you see it is now instead of 1 it's at 2. So this is actually minus 12 dB per octave. So what I'll do now here, I'll come down by 18 dB and go by 1 octave. So where is 18 dB? From here, if I just come till here, it is 20. Now this is 18. See here, now this is 18 dBs and this is 1 octave. Octave means I was there at 50. I'll go to 100. So this is 100. So I will join this line. So this is what? Minus 60 dB per decade, which is got using minus 18 dB per octave. Octave means you came down by 18 dB. Octave means twice the frequency. You are there at 50 radian per second. 50 into 2 is 100. You came here. So we are done with this. So let me write a 0 dB line. So this is the 0 dB line here. So what is omega PC? Omega PC is 7 radian per second. So that's what is omega PC is. Omega PC. So we are now supposed to find the gain margin of the system. What is gain margin with k is equal to 1. So we know that gain margin is negative of the magnitude of g of s into h of s with omega equal to omega pc. So since omega pc is 7, now you can see this is 9, 8, 7. So this is 7. Let me just go up here. So it is 9, 8, 7. 7 is here. So this is my 7. See, now this is 7 radian per second. At this point, how much is the gain? So now the gain here is, this is 30, 32, 34. So it's actually minus 34. See, now this is at 30, it came down by 2 divisions down, so it is minus 34 dB. So now gain margin with k equal to 1 is actually 34 dB. 34 dB. So that's what it is. Let us go to this equation. So we were supposed to find gain margin with k equal to 1. So as per this graph, gain margin with k equal to 1. So this is actually gain margin. So what is this gain? So this is gain at omega equal to omega pc, which is minus 34 dB. What we have to find? How to find gain margin? It is nothing but negative of minus 34 dB, which is nothing but 34 dB. This is gain margin. That's what we did here. So now let us come to this. Okay, in the example we took it as x dB. So now let us take the specific value. It is now 34 dB minus 15. So what is 34 minus 15? It is now 19. So it is 34 minus 15 is 19. So what is the value of k now? K is equal to 10 to the power of 34 minus 15 by 20, which is nothing but 10 to the power of 19 by 20. So it is 10 to the power of 19 by 20. See, it comes out to be k is equal to 8.91. So the value of k, if it is 8.91, then the system will have a gain margin of 15 dB. How to verify this, whether this 8.91 is correct or not? So this ends the problem here. So we actually found out the value of k as 8.91. So the problem is done here. So just to identify, just to ensure that everything is fine, we actually found magnitude at origin by considering this k as equal to 1. So if you consider this k is equal to 8.91, so what will be this MAO? MAO is 20 log of 8.91. It is plus 20 dB. The plus of this, so this will be 38.99, which is equal to 39 dB. So this is actually at 20 dB with k is equal to 1. So now this is the 0 dB line with k is equal to 1. Now how much you are looking for? This has to become 39 dB. So what I have to do is I have to totally shift this up. I have to shift this entire thing up. Instead of shifting this up, shall I bring this down? If I bring this down, by how much I need to bring down? So I need to bring down by 19 dB. So I'll just bring the 0 dB line here. So I shift the 0 dB line such that the magnitude at origin becomes 39. So 39 is 19 dB somewhere here, halfway down. So this is the 0 dB line. This is now the new 0 dB line. So this will become 39. So this is with k is equal to 8.91. So if you actually find how much is this, if you actually find this from this new 0 dB line to this omega PC. This happens to be a gain margin of 15. This should be 15 dB. Let us find out, is it 15 dB or not. It is 15 dB. Can you see here? This is actually from here to it is 11. 11 plus 4 is 15. 11 plus 4 is 15. So this is verification that 8.91 is a correct answer. 8.91 is a correct answer. So let me repeat this again. Actually what we did, the problem was we were asked to find the value of K for a gain margin of 15 dB. Now what is the procedure? The procedure is to assume the value of K is equal to 1 and plot the Bode plot, find the gain margin with K equal to 1. Once you know the gain margin with K equal to 1, you have to use this equation to find the K for a given gain margin. So what we did, we took the value of K is equal to 1, we found what is magnitude at origin, which comes out to be 20 dB, and we wrote the slope table by considering all the terms. Be careful, the term should be in the increasing order of their cutoff frequencies. And then we found the phase equation. After writing the phase equation, we actually found what is omega PC, that corresponds to a phase of minus 180 degree, which happens to be 7 radian per second. Then we plotted the Bode plot, this blue one. So this is 0 dB line, and we actually plot this 3 different slope, minus 20 dB decade, minus 40 dB. For minus 60, since the space was not there, we took the equivalent of minus 60 dB, which is nothing but minus 18 dB per octave. We came down by 18 dB, gone by 1 octave. Octave is nothing but twice the frequency. It is twice the frequency. In case of decade, we take it as 10 times. So it is 10 times the frequency. Here it is twice the frequency. So now afterwards we found the gain. So gain margin, gain is coming out to be minus 34 dB at omega PC. So gain margin happens to be negative of that, which happens to be 34 dB. So then we went back to that equation and found the value of this K using this equation of given gain margin with K equal to 1 minus given gain margin. So this X becomes 34 minus 19 is 15 is 19. Then the value of K comes out to be 8.91. Okay, the problem get solved here. Just for verification purpose, we actually shifted the 0 dB line from here to here. The amount of shift is actually that difference of gain margin with K equal to 1 to given gain margin. So how much is the shift? Shift is actually 19 dBs. So shifted by 19 dB down. So when this gone by 19 dB down, if you actually now find what is the new gain margin with this as 0 dB. So this is what a new 0 dB line with value of K, which should result in a gain margin of 15 dB. That's what we are trying to find out. We want to just verify. See, now this is your omega PC. This is omega PC. If you find from this new 0 dB line to this, so this comes out to be 15 dB. So this is actually minus 15 dB. Gain margin is negative of gain at omega PC. So it is minus of minus, which is 15. So the value of K, which is found out to be 8.91, is correct. 8.91 is correct. Hope okay, this will make sense. It's very easy. You can just easily do this. Okay, now let us consider the same problem and try to find out what is the value of K for a specified phase margin. So let me just take what is this? GFS into HFS is equal to K by S into 1 plus S and 1 plus 0.02 S. Let us try to find the value of K for a phase margin, of margin of, maybe let me take it as I'll just take it as some 60 degrees, some 60 degrees. It can be any phase, it can be any phase. Now how to find this K for a given phase margin? So we actually saw in the previous problem how to find the K for a given gain margin. Now it is phase margin is given and you are asked to find so and so. So now we know that phase margin is given by, okay, let me just write, phase margin is given by 180 degree plus phase at omega GC, phase at omega GC. So this is what the equation is. Now since you know these are the equation, what is the phase margin that is asked for? The phase margin that is asked for is 60 degree is equal to 180 degree plus phi at omega GC. So from this equation, shall we write phi at omega GC as equal to 60 degree minus 180 degree, which happens to be minus 120 degree. So this is phi at omega GC is equal to minus 120 degree. So now what we'll do is we will use this value of phi of omega GC and go to this phase equation and try to find out omega GC, try to find out what is omega GC. So what we'll do is, this is phi of omega GC is equal to minus 120 degree is equal to, what is your phase equation? Phase equation is this, it is minus 90 minus tan inverse of, instead of omega, let us write it as now omega GC, minus tan inverse of 0.02 omega GC. Now you feed this equation, try to solve for omega GC. So what I'll do, see what we did. This is the value of, this is the transfer function. We are asked to find the value of K for a phase margin of 60 degree. Of course, for this particular thing, you are not supposed to plot the Bode plot at all. So that's what you're trying to do it here. Without plotting Bode plot, you can do it. So now we know that phase margin is given by 180 degree plus phase at omega GC. So now we know what is the phase margin required. So we are trying to find what is the phase at omega GC, which happens to be minus 20 degree. So now using the equation, we are trying to find what is omega GC, which should give a phase angle of minus 120 degree. So it is minus 120, alpha equals minus 90 minus tan inverse of alpha A minus tan inverse of 0.02 alpha A shift cal. Now this will give me omega GC. So omega GC is 0.562. So what does this actually omega GC of 0.562 mean here? Suppose if you come to this, okay, let me just redraw it. So this is a bit cumbersome. Too many things have already happened there. So let me just redraw it for clarity purpose. So this is 40, 20, 0, minus 20, minus 40, minus 60. Let me start from, okay, now it is, of course, you have to plot the graph again with k equal to 1. If you are plotting the graph with k equal to 1, you plot the magnitude plot. So now this will be 20 dB, and using the same slope table you can come down here. So let me just draw this. This is done. Then okay, after 1 it is 40 dB per decade. I just came down by 40 dB, 1 decade. This will go up to 50. This will go up to 50 radian per second. Now this is 2, 3, 4, 5. Fine. Next this will come down by 18 dB. This is 18 somewhere here. This is now. This is 20. This is 2, 12, 14, 16, 18 and 1 octave. So I am done with the 3 slopes. So now it is minus 20 here, minus 20 dB per decade. This is minus 40 dB per decade. This is minus 60 dB per decade. So I have this at, so what is omega GC given? So this is actually 0.1, this is 1, this is 10, this is 100, 1k, so on. So now omega GC for a phase margin of how much? 60 degrees is actually 0.562. So I have to shift my 0 dB line such that omega, this is omega GC 1 radian per second with k equal to 1. So what I have to do is I have to shift this so that it's at 5.2. So let me just take it as approximately 5. This is 5 here, so I am here 5. Okay, this is 5. Correct? This is actually. So have I shifted 0 dB line by 6 dB above? Is this now 0 dB line for a K which will give a phase margin of 60 degree? This is new 0 dB line, new 0 dB line. So for this since it went by 6 dBs, does this 20 will also become 14 dB? Because you are shifting up by 6 dB, then this will also reduce by 6 dB. So it is 14 dB. Now, shall we say, of course, now this is done. We have plotted the graph also. Now this is magnitude at origin, magnitude at origin. So let us do that. So shall we just find out? So what is omega GC is found. So using this, what is MAO for a K is equal to K resulting in phase margin of 60 degree? Is this not equal to 14 is equal to 20 log K minus 20 log 0.1? So since we know this, we can actually find the value of K. So what is K now? So it is 14 alpha equals 20 log alpha A minus 20 log 0.1. Shift cal, you will get the value of K. So K is coming out to be 0.501. If the value of K is 0.501, then the phase margin is 60 degree. Phase margin is 60 degree. Okay, this is graphically how we can do it. Since we have plotted the graph, I am just finding it graphically. We can actually find the value of K theoretically also using equation. How to do that? Because we know what is omega GC. We know the magnitude equation. So what are the magnitude equation? Magnitude equation for this is, shall I write it as 20 log K minus of 20 log omega minus 20 log, or it is 10 log 1 plus omega square minus 10 log 1 plus 0.02 omega whole square. This is my magnitude equation for this plot. Now if I equate this to 0 dB, does this become omega GC? Does this become omega GC? Does this become omega GC? So now the moment when you make this equal to 0, this will become omega GC. Since I already know omega GC, how to find 20 log K now? So shall I just make this 20 log K to come on this side? So now this is the only unknown. I know this, so if I bring it here, so what I'll do is 0 alpha equals 20 log alpha A minus 20 log how much is omega GC? Omega GC is actually 0.562. 20 log 0.562 minus 10 log 1 plus 0.562 square minus of 10 log open the parenthesis 1 plus 0.02 into 0.562 whole square. Okay, if I do shift cal, whatever value of A I'll get will be the value of K theoretically. I just read the same equation. Okay, see now it is 0.644. This is the theoretical value. This is K is equal to 0.644 using equations. If you plot it using graph, you will get it as 0.501 because you are slightly approximating, you are writing asymptotic plot, but actually it will be K will be equal to 0.644. What we did here is we actually substituted to this equation all the terms that are corresponding to this, that is phase equation, magnitude equation, omega GC here, omega GC here. So we know that this is a theoretical equation considering all poles. So the value of K comes out to be 0.644. And of course using Bode plot we got it as 0.501. Of course we know that we can still get the same 0.501 as the value of K even using calculator, provided if we consider only those terms which are contributing at omega GC. So what are the terms that are contributing at omega GC? The terms that are contributing at omega GC are K and 1 over S. So in this equation, if I discard this and this, and equate this to 0, I'll get very close to this. So what I'll do is, I'll do the same thing now. I'll just retain this A value, I'll retain this S term, but I will delete all these terms. I'll just delete all these terms. You can see I'm deleting all the terms which are not contributing at 0.56. I'll just retain only this. Now I have only K and this. So if I solve for this, I'll get 0.50, very close to that. Can you see it is 0.562? It is very close to this. So now this is the value. Of course, why it is slightly away is because this shifting may not be exactly 6 dB, so there is slight variation. So this is a asymptotic plot. This graph variation will going to certainly end up with some change. Hope it is fine. Of course, it's you can see it's exactly matching. This is exact because I cannot find that exactly 0.56. Actually, I went to 0.5. If I just go to 0.56, this comes out to be slightly very close to this value of. Now K value is actually K is 0.501 using this plot. Now we are looking at it's very simple. You start with the given equation, try to find out what is phi of omega GC for a phase margin of 60 degree, which happens to be minus 120 degree. So find that omega GC which results in a phase of minus 120 degree, which is this. And what you can do is you can identify this, you can plot this magnitude plot with K equal to 1 and identify 0.562 2 as the omega GC, try to shift this 0 dB line and try to know what is the magnitude origin. So once you know magnitude origin, then all this stuff. This is using plot. If you are using the equation, you can use the magnitude equation, equate this to 0, substitute this omega as omega GC, you can find the value of k. This is by considering all terms. Suppose if you want to match your answer with the Bode plot one, then you may have to discard these 2 points, or you have to discard those terms which are not contributing at omega GC. In this case, these 2, if you equate it, you will get it almost very close to the asymptotic value. Hope okay, it's understood. So you need to conceptually understand. So I could able to write 2 different values of k, but don't get confused. This is using plot, this is using plot, this is using equation, and we got one more value of 0.562 as the value of k by discarding these 2 terms which are not contributing at omega GC. So all the values are okay, all the values are correct, so nothing is wrong, but whatever you write here, it's fine, but we are looking at whether you are following the procedure or not. Thank you. So in the next video, we will see one more category of finding the value of k when omega GC is given,